Hi. In this video, we're going to talk about some vocabulary associated with lines. It's section 4.4 in your textbook, and we've been graphing lines. We should say we've been graphing equations that end up looking like lines in section 1, and then we started to use this word slope to help us describe how the line slants. And the slope, first and foremost, the sign tells us whether it's slope, which direction it slopes. So this is sloping down to the right, it would have a negative slope. If it's slanted in the up to the right, we would say it had a positive slope. And then we had those two special cases, zero slope and undefined. And then, of course, the number itself, the magnitude told us how much it slanted. Well, now we're going to introduce some new vocabulary. Y-intercept, where the line crosses the y-axis. X-intercept, where the line crosses the x-axis. And as we saw in the do now, the warm-up, we realize now that any equation that has a certain format will always create a straight line. And the format that we've been looking at is where the y, the output, is equal to some number times the input variable x plus a number. So the ones we just saw were for that saving money. We saw equations like this. I forget if it was negative 15 or negative 20. Okay. And we saw all these lines, we graphed them on Desmos, all these equations when we graphed on Desmos created a straight line. So this group of equations are called linear equations. And if we have it specifically written this way, and that's what I really want to solidify, what does this way mean? Then we can look at it, know it's a line, know that all the solution points will lie on a line, and we will also know just by looking at it that this number in front, multiplying the x, will be that rate of change, that slope, that description of the slant of the line. And now we will know that this plus number, the constant, is where the equation crosses the y-axis, right? And we saw that if there's no number being added or subtracted, so this equation we saw in the warm-up, that this only means that the y-intercept is 0 and it goes to the origin. And those were the proportional relationships you studied in 7th grade. So that's what I kind of want to summarize in this video. And this would be something that I would recommend coming back to for further understanding. So what do we mean by slope-intercept format? Okay, we mean y, the output variable, is isolated on one side of the equal sign. The variable y has a coefficient of positive 1. So notice no negative signs here. We can't have a negative sign. And that 1 is never written in. The variable x is on the other side of the equal sign and will be multiplied by a number. So negative 15, 20, 20. Okay. Sometimes we might see the x alone like this. That just means the coefficient there is 1 also. And there may or may not be another number added on. So plus 100, no number plussed. Okay. If there's no plus number, it means it's 0, and we just don't write it. So whenever you see an equation in this format, you know it's linear, and you can start to visualize the line. Which direction it slants in, how steep it slants in. So here's an example. This equation is in slope-intercept form. Y is alone, isolated. Negative 4 is the multiplying number, so that's our slope. The plus number, well, it's minus, but that means it's plus negative 2. Here, this one, we might not think it's in slope-intercept form, but watch how I'm going to show you that it really is. This time, there's no x. That just means the slope is 0. We saw that this is a horizontal line. Slope is 0. So we don't write that in typically. y-intercept is plus 4. Here's another one, y equals x minus 3. Slope is 1, not written in. Y-intercept negative 3. Here's the equation y equals 23x. No plus number, that means the y-intercept is 0. The slope is the multiplying number. Notice you can have a whole number for the slope, but you could also have fractions. I'll show you those as well coming up. What's not slope-intercept form? Okay, so this means right at this moment, it's not in slope-intercept form. This one is not. Y is not isolated on one side. It has the minus 5. 2y equals 4x plus 2, not y-intercept form. Y has a multiplying number of 2, coefficient of 2. Third one, negative y equals 2x minus 3. The y is a coefficient of negative 1. So these three are not in slope-intercept form. That doesn't mean we can't change it into slope-intercept form. So for this one, add 5 to both sides. So I might at sometimes say, here's an equation, find the slope and the y-intercept. I see it's not into slope-intercept form, but I'll try to get it into slope-intercept form. Here, I could add 5 to both sides to get y equals 32x plus 5. Now I can see the slope and the y-intercept. Here, I have a coefficient of 2. 2y's is equal to all that. So if I divide both sides by 2, I can now get the slope and the y-intercept. Now what do I do here? Two options. I can either divide by negative 1 or multiply by negative 1. I like multiplying. If I multiply by negative 1, both sides, negative y times negative 1 is y. 2 times negative 1 is negative 2. Minus 3 times negative 1 becomes plus 3. So when something's not in slope-intercept form, but you think it probably is linear, you can try and rearrange the equation to put it into slope-intercept form.